Okay, hi everyone. So we're back, and as I said earlier, our next speaker is Josep Sobrepere, and he'll be talking about React-RxJS. So I'm just going to bring him in now. Hi, Joseph. Where are you joining us from?
From
From
Barcelona.
Barcelona, correct? Yeah.
Yeah.
Okay. How's the weather over there? Is it warmer than here?
I think so. It's been rainy these days, but now the sunshine is coming up now, so it's pretty nice.
Yeah, here as
Thank you.
well. Yeah. So we'll probably have a good day today. Yesterday was really good as well. Okay, perfect. So let
Awesome.
me then pull up your slides so we can get started with your talk. Okay, perfect. That looks good. So I'm gonna let you get started, and I'll come back after your talk.
For sure. Thanks a lot. Thanks a lot, Jen. Well, welcome to my talk. The name of the talk is React-RxJS, bringing reactivity to React. Well, first off, thanks all for having me at RxJS Live. It really is an honor for me to be speaking in this conference. Since the name of this conference is RxJS Live, I guess that I don't have to convince you about the benefits of using observables and RxJS, right? Also, even if this is not a React conference, I'm going to assume that most of you are somewhat familiar with React. For those of you who are not familiar with React, I have to warn you, this talk is going to be a little bit difficult to follow. But there are some parts that you may find interesting anyway, so if you want to stick around, you're very welcome to do so, of course. So for those of you who have experience with React, have you ever wished that you could use RxJS observables for managing the domain state of your applications? Not as a means to aid a deficient state management library like we often do, but as a fully featured tool for managing our domain state? Well, I certainly did. And in this presentation, I'll be explaining why, thanks to React-RxJS, we'll be able to use RxJS as a very powerful state management library. In this talk, I'll be highlighting three benefits of using React-RxJS. The first one is that it allows us to derive our state using streams, which, as we will see, it's something that it has a lot of benefits. One of them is that we won't have to worry about triggering undesired React re-renders. The second one is that these bindings fully leverage React suspense, both for data loading and for code splitting, and how thanks to this, we can greatly improve the loading times of our React applications. And the third benefit is that using streams for handling domain state produces code that it's much easier to navigate, therefore making our solutions easier to maintain. Hi, I'm Josep Maria Sobrepere. I'm the creator of React-RxJS, the co-author actually, together with Victor Oliva. I'm a front-end architect at Adaptive Financial Consulting, the company that I work for. I'm the creator of another library that I no longer use, thankfully, called Redux, and I make small contributions, modest contributions to some open source libraries like RxJS, React Redux, React Router, among others. And if you want to follow me on Twitter, my handle is Josep Tech. If you don't want to follow me, that's okay. You won't be missing much. Anyways, let's get started. The first thing that we're going to do is we're going to build a demo application. Okay. The purpose of this is to highlight why, for certain applications, using React as a state management library is less than ideal. And why, for those kinds of applications, React-RxJS could be a powerful tool for improving both the maintainability and the performance of our React applications. I've brought this demo up from Mitchell's Weststrait's talk, MobX, or going from mutable to immutable to reactive state management. In his talk, Mitchell solves the same problem using different implementations and then compares the trade-off of each solution. And of course, he shows how solving that problem using MobX has a lot of benefits. I highly recommend you watching his talk, and thank you so much, Mitchell, for allowing me to use this demo in my talk, the demo up in my talk. So in here, we're going to be doing something similar. We'll first solve this problem using React. And by the way, our implementation is going to be quite different from his implementation. And then we'll solve the same problem using React-RxJS so that we can compare the trade-off of each option, okay? One thing before we get started with that, that I want to warn you about is that for the purposes of this demo, I've put all the code in one file, which is something that I will never do in a real project. So please be a little bit indulgent and don't judge me for that. Okay, thank you. So yeah, let's have a look at the app that we're going to be building. Okay, let me walk you through. Let me check something. Yeah, let me walk you through this demo app so that you understand how it's going to work. So this application has a section with order lines right here, okay, and a section with exchange rates that apply to these order lines right here, right? The user can edit the price and the currency of each order, and when they do so, the base currency price also updates, okay? The only tricky thing about this is that the base currency price, which is this field here, depends on the currency rate, which is defined here, meaning that these updates are going to update these order lines and so on and so forth, okay? Just one small clarification. I'm going to call this column here, this file, I'm going to name it the base currency price to distinguish it from this price. The base currency price because it's the price in the base currency of the user, which in this case happens to be the pound, okay? Then we also have this add button that will add some random orders that then the user can edit. And then finally we have this total here, which is the sum of all these base currency prices. That's it, okay? So let's start coding it. Let me 1 second. All right. Let's start coding. Let me first explain the starting point. So our awesome product designer has set this up for us. It's a bunch of presentational components without any state. And our work is to bring this to life, okay? So this is our root component right here. And then we have the orders component, which is this one here. And then the currencies component, which is this one here. Let's see them. Let's see them a little bit closer. The orders component, super straightforward, just a table rendering the different order lines for each order. The order line component receives an order and prints it. One thing to notice, though, is that the base currency price, right, it's not a property of the order because it's derived data that needs to be derived from information of the order and information from the rates. So for now, since we don't have any sort of state, it's being hard-coded to 1000. Then we have the currencies, this section here. And it's pretty much the same thing. It's a table with a bunch of currency rates. And this is the currency rate, okay? Then notice that here, I haven't highlighted it, but here we have some utils that we'll be using with the initial orders, the initial currency rates, the formatting function, and these kind of things. All right, let's start coding this. So the first thing that we've noticed is that the currencies are being used in both components, in the orders and in the exchange rates. So they are the perfect candidate to put them in context. By the way, if you cannot follow this part because you're not very familiar with React or you're not familiar on how React hooks work, don't worry too much about it. What it's important is that you understand the thought process that a React developer goes to when using React as a state management library, all right? So yeah, so we're going to put the currencies in context, and this is how we do it using React, or one way of doing it using React. We create some context for the initial currencies. We can create an idiomatic hook for accessing those currencies that we have in context, right? And then we can create a provider for the currencies that we'll call it currencies provider. Then we can use this hook in the different components that are using these currencies. Let's do that. So we replace these hard-coded values with these hooks. Same deal here. And then in the root component, we put the provider. So now nothing works. Still nothing works, but at least the currencies are coming from context. All right. Cool. Let's make something work. Let's make the exchange rates work. Okay. So something that is important when working with React is that the general recommendation is that we should keep our state as local as possible until we have to lift it. So let's imagine that we are a developer working in a Scrum team, and we pick up this story that says, as a user, I want exchange rate. I want to be able to update the currency rates of the different currencies, right? There is no reason for us at this point to lift the state, so we're going to keep it local. And if later we have to lift it, we will lift it, right? That's the philosophy of using React as a state management library. So it's super easy to do that. We come to the currency rate component, this one right here. And instead of using this hard-coded value, we bring the use state from React. We pass the initial value, and then React is going to give us the state that will be changing and the state header. We plug the state and the setter, and now all of a sudden, this should be working. Okay, cool, and it is working. Nothing else works, but this works. Also, notice that we're using the React development tools in order to keep track of which components are being re-rendered. So awesome, this is working, and only the components that are being updated are re-rendering. Perfect. Well, let's do the same thing with the orders. Let's first make these two fields work. Same deal. Let's keep the state local unless we have to lift it. Super quick. We go to the order line component and we apply the same trick. We use the use state hook. We pass it the initial values. We have the setters. We plug the setters in, and now all of a sudden, this is working. Perfect. It kind of looks like we're like at least like 60% there, right? Like it's like, wow, just we put a couple of hooks and we're almost done, right? You wish, right? Anyways, so now is when we realize, we need to calculate the base currency price. And obviously, in order to calculate the base currency price, we need to access to the price rates that are living in the state of the exchange rates component. So, well, we are React developers. We know the drill. When this happens, what do? We lift the state, right? So it's time to lift the state. Well, let's create another context provider. It's good that we create this currencies provider because now we'll be able to reuse it by adding another provider, as we'll see in a moment. So we create the currency rates context. Now, what this context is going to hold is a record, an object, where the keys of this object are going to be the currencies, and the values are going to be the value of that currency rate, okay? So we can see here, it's string and number. String is the ID of the currency, and the number is their value. Like we did before, we create this idiomatic hook here, use currency rates, and we plug the new provider here. And that's it. We use state, passing the initial currency rate, which is this record, this object that we are going to have in context. And then the only thing that we need to do is come to the currency rate component and replace the use state with our new use currency rates hook. Okay, let's do that. We come here, we replace it, we access our currency, and we update the unchanged so that only our currency gets updated. Perfect. Let's see if this works. And it's working. However, you see, now every single component is being re-rendered. Well, that makes sense because now every time that we trigger a change, we are triggering an update to each one of these components because now they are all receiving the object that we put in context. So it's okay. We know how to deal with this. Let's avoid these re-renders. It's easy. The only thing that we need to do is we need to spoon feed the currency rate component with every single property that it needs, and we lift this state a little bit higher into the currencies component. So let's do that. We come here and we lift it, right? We access the currency rate from here, and we are going to spoon feed the currency rate with exactly everything that it needs. And we're going to use the memo higher order component to enhance this component so that it doesn't update when its properties haven't changed, right? Okay, let's see. Yeah, okay, that worked. Now, at least the different rows are not being re-rendered. Cool. So we're finally ready to access the currency rates from the order line so that we can calculate the base currency price. Let's do that. We come to the order line. We use our new hook for accessing the currency rates. And with these utils, with this function that comes from the utils, we calculate the base currency price for this order line. Cool. So that works. We can see that it is updating. Perfect. But now let's see what happens. Oops. Now, when we change one currency, every single component updates. Even when we change a currency that is not being used there, every single component updates. Of course, that's happening for the same reason that was happening before. This hook is triggering an update to every single order line. So whatever. I mean, it is what it is. It's triggering updates. There are ways to avoid it. But now, now we realize that, okay, we're going to have to leave this state anyways, because we'll have to add the sum of all the base currency rates from here, right? So, okay, now lifting this state is a little bit more complicated than the other one because we can add orders, we can edit different properties. And when these things happen, we know what to do. We can use a reducer then we can use the use reducer hook that will give us a dispatch that we can pass down so that we don't have to create other functions that could be triggering re-renders. So let's do that. We go to the top and where we have all the context. And first thing that we're going to do is we're going to add the reducer here. And then we're going to create its context so that we can access the orders from anywhere. And we're going to put in context the dispatch, and we're going to put in context those orders. Again, what we're going to have in context is a record, an object, where the ID of the object is going to be the key, and the order is going to be the value of the object. Okay? Now, we're not going to fall for the same trap that we fell before. We know that in order to avoid unnecessary re-renders, we'll have to spoon feed the order line component with everything that it needs. So let's do that. We go to the orders component, we get everything that we need, and we spoon feed the order line component with exactly every single property that it needs so that in the order line component, we can use memo to avoid re-renders, okay? So now this is finally working without triggering unnecessary re-renders, as we will see in a moment. I mean, some re-renders are happening, but at least now each one of the order lines, the non-affected order lines are not being re-rendered. Perfect. So we're almost done. Sorry, this was a little bit long. Let's wrap it up. Now we want to make the add button work, right? Now we have to be careful because if we access dispatch from this component directly, then we are going to be triggering updates to the whole application anytime that we change an order. And that's because we've put the dispatch in the same context that we put the state for the orders, which is the most common way of doing this. So there are different ways of avoiding this. We could have created a context for dispatch and a context for the orders, but almost no one does that. So another way to avoid triggering re-renders to the whole app is to create a small component just for, oh, sorry, I forgot to put the orders provider here. It's to create a small component just for triggering the add dispatch action. That way, the re-renders will be isolated into this component and not in the whole app. Okay, so that's what most people do. So we put this add order button component, and then this is working perfect. Last, we're going to make the order total work. Okay. So how do we do that? We use all the hooks that we've been creating, and then we recalculate every single base currency price from here. Despite the fact that this has already been calculated in the orders component, we need to recompute it again because this component lives outside, and then we add it and we put it here, and that works. It's a little bit unfortunate that we have to do these things, but there's no easy way with React for creating derived state. So, there are alternatives, but they are not nice. We could have like we could tightly couple the two reducers, and there are other ways of doing this, but I don't think that there are many elegant solutions for solving this problem using React, at least, or using just React as a state management library. So now this works. And it gets updated. But let's see what happens when we update a currency that it's not being used inside the order lines, like the Canadian dollar, right? Well, this component is being re-rendered. And of course, it's being re-rendered because React doesn't know that this currency rate is not being used in any order, so it needs to recalculate to figure it out, right? I mean, such is life, right? But we're done. Thanks for your patience with this, but it was necessary to show you what I'm going to show next. So this is the code that we've generated using React. There is also some code that it's living in some of the presentational components that maybe shouldn't be living there because it's domain code. But anyways, yeah. So I don't know about you, but I find this way of managing state very tedious. Every time that we have to leave the state, then we have to start worrying about avoiding re-renders. We don't have an easy way of defining derived state, so we end up putting business logic inside the components or tightly coupling reducers that maybe they shouldn't be tightly coupled. And even after having applied all the recommended performance optimizations that we can use with React, we still see components that are being recomputed for state changes that don't affect them at all. So why is that? And I guess that some of you will be thinking like, that is when I say that this is because React is not reactive. Well, it's not that. I mean, sure, React maybe it's not reactive, but we can make it reactive with a reactive state management library. So the real reason why I think that this happens is because we're conflating the view tree with the state graph. What does that even mean, right? Well, if we had to draw a diagram that represents how our components are being composed, that diagram would look more or less like this. Here we have a root component, which is this whole thing, and the root component has these currencies, which is this thing here. For the lack of a better name, we have the summary component, which is the one holding the add button and the totals. And then here we have the orders for the order lines, right? This is this tree represents the way that our components are being composed, right? However, what if we had to draw a diagram that represents how we would like to compose the state? Then at least the diagram that I'll be drawing will look like this. So basically, we are defining each piece of state like if we were defining the cells of a spreadsheet. For instance, the orders total depends on the base currency price of each order. Anytime that one of the currency prices, the base currency prices, updates, the orders total will be recomputed. And if they don't update, it won't recompute, right? We are declaring its dependencies. Similarly, the base currency price of each order depends on the order price that the user set for that order, this one here, and the currency rate of the selected currency. So if the user has selected the US dollar, then it will depend on the currency rate of the US dollar, right? Like here. If the user has selected the Canadian dollar, it will depend on the currency rate of the Canadian dollar, and so on and so forth. With this rate and this price, we can calculate this one, right? So if every time that we define a piece of state, we define it based on its dependencies, then we will be creating a loosely coupled solution. And we'll be creating a solution where we can derive the state. So it's not only that we'll make sure that the React doesn't recompute when it doesn't have to, is that we'll be able to compose this state farther down. the same in a way that it's kind of similar to the way that we compose our components. However, if we use React as our state management library, we won't be able to define our state like this, because React treats our state as a black box. It doesn't understand its hierarchy or its relations. What's even worse is that we'll be using a tree for modeling a graph, because this is not a tree. It kind of looks like a tree, but it's not. It's more like a graph. We can see that some nodes here have more than one edge. And that may be okay if the state of if the state graph of your app completely overlaps with the view tree. But if it doesn't, then I don't think that we should be using React as our state management library. I might rather to use React for modeling the view tree, and then outside of React, use a state management library that allows us to define our state based on their dependencies. In other words, a reactive state management library. Something that looks more or less like this. That's what I would like to have. Okay, so ideally, I would like to be able to compose my components using React here. And I think that RxJS could be a very powerful tool for building this state graph. However, RxJS alone can't do that by default. It needs a little bit of help. The reason being that RxJS observables by default are unicast. And when working with React, and for deriving those states further, we need to work with observables that are multicast and that they are replayable. And we need to do that without creating memory leaks, okay? Which is possible, but it needs some enhancements. Also, we need to have a way that we can connect these little pieces of state directly into React in a way that it's almost transparent to the user. So here's where React-RxJS comes to play. React-RxJS enhances the normal streams that you will produce with RxJS. And it provides, every time that we do that, it provides a hook so that we can use that stream inside React, inside our React components. And it gives us a stream that we can use to keep composing that stream, as we'll see in a moment. So if we keep doing that, then we'll be able to handle our state, to manage our state like this. We'll be able to define our state like the real graph that it is. And what will happen then when the error rate value changes? Like, what will happen if it changes and it's not being used in any other line? Well, this component will update and nothing else, because right now, this will not trigger any other state changes. And what will happen if the Indian rupee updates? Well, the exchange rate for the currency will update. It's being used in one order line, so that one will update. And it's being used in the other total, so the other total will update, and nothing else, right? So it's not only that we'll be defining a state that it's composable, it's that we'll be helping React knowing when each component needs to be updated, right? So let's see how that works. Let's solve the same problem that we solved before using React as a state management library. Now let's solve it using React-RxJS, okay? Sorry. The starting point is the same as before. And the first thing that we did before was we put the currencies in context. I don't know if you remember, but that's the first thing that we did. So let's do the same thing, but using React-RxJS instead, just for fun, okay? So if we want to put the currencies in context, this is one way that we can do that using React-RxJS, okay? So let me explain what's happening here, because this is definitely code that can look a little bit weird at first. So bind is the secret sauce of React-RxJS. Let me explain what bind does. Bind is a function that it takes at least one argument, the observable that will be emitting values that we want to use inside of React. In this case, it's empty. We'll explain why later. The second argument, which is optional, is the default value that we will be using until this observable has emitted. Okay? Then bind returns two different things: a hook, so that we can use those values inside React, and the enhanced version of an improved version of the input observable, okay? So that it's shared and it's replayable, so that we can keep deriving from it. Also, another improvement that this observable has is that if the original observable doesn't emit synchronously and we provide a default value, this observable will emit synchronously that default value. Okay. So this is the observable that we can use later on for keeping deriving for deriving more things from it. Okay. And this is the hook that we can use inside React. Now, maybe using bind here looks like an overkill, but it has two advantages over using React context. Well, the first one is that it is a lot easier to set up. And the second one, which is the most important one, is that if in the future the currencies become a dynamic value, then we can replace this empty observable with the real observable that will represent those dynamic values. And so this empty here is like a placeholder for whenever we need to bring whenever we have to bring this to life in the future. Okay. Moving on, let's make something work like we did before. Oh, hold on a second. Let's use this observable that we created in the components that are using it, and we're done. Now let's make the exchange rates work. Okay. So far, like before, like now nothing is working because we haven't. The only thing that we've done is to put these currencies in context. So now let's make the exchange rates work. Okay, this is how we can do it. What's going on here? Let me explain, because this code can be a little bit intimidating at first, but once you get used to our API, it's not that complicated. The first line that's highlighted uses this util called create key signal to create a signal for each currency. In the context of React-RxJS, we use the term signal for referring to external events. Every time that we create a signal, we want to have an observable for listening to those events and an event emitter for emitting those events. Using RxJS terminology, this is like saying that we want to separate the observable from the observer of its underlying subject, okay? But the idea is that a signal is something that we create when we want to listen to external events, okay? Now, sometimes we want to partition these signals so that each instance has their own signal. Like here, right? We want for each currency to have a signal for when the user is editing that currency, okay? For those cases, we use create key signal. We have another util that it's called create signal, but for here, we're going to be using create key signal, okay? Create key signal returns a function for accessing the observable of each instance. This is what we call a factory observable, and it's something very useful in the context of React-RxJS. And then it returns an event emitter. The first argument of this event emitter is going to be the key, and the second argument is going to be the value that will be received inside the observable. Okay. It sounds more complicated than it is, but believe me, it's not that bad. And then here we can see how bind this time is not taking an observable; it's taking this factory observable, right? Let me explain what this means. This is very similar to using defer, if you are familiar with the defer operator of RxJS. From here, we can decide for each key the observable that we should be using, okay? We could have used rate change directly because it has the same signature, but I added the full function so that it's clear that what we're doing here. And similarly, like we did before, here we can provide the default value, okay? So this is going to give us a hook, just like before, and a factory observable so that we can keep deriving from it. As we'll see later, this is going to be very useful. Okay, so let's plug this in. We just come here. Notice that this is kind of similar to use state, but outside of React, right? Kind of similar. And then here we access the rate for this currency. This is going to give us the rate values, and here we plug the event emitter. We pass the key and we pass the value. Okay, now this should be working, and it is working. Perfect. Let's do the same thing for the order lines. Okay, so for the order lines, the first thing that we want to do is we want to have a hook that give us the IDs of the orders. Why? Because the orders component, the only thing that it's going to be responsible of doing is instantiating the different order lines and giving them their own ID. Then the order line component will be responsible of handling the order. Okay, so for now, like we did before, we're going to use this empty observable as a placeholder. Later on, we're going to replace this empty observable with the actual observable once we plug the add button. For now, let's use it as a placeholder. Later, we'll make it work for real. Okay. Then we use the user order IDs inside the orders component, and that's it. We pass the IDs, and when and we let the order line component handle the order line for themselves. We don't need to spoon feed it anything. All right. Now, excuse me. Now let's make the hook for the order line. Similarly to what we did before, we're going to create two key signals. One for listening to the price changes of each order line, and another one for listening to the currency changes of each order line. And these are their event emitters, of course. Okay. And here, this is the interesting bit. We're using the factory. We're using the bind factory overload to create an observable for each one of these orders. So we access to the initial order, and then we create an observable for the price. This is the same as doing price change pipe start with. I like concat better than start with for some reason. This is a pet peeve of mine. Sorry, it's just because it reads on this in the actual sequential order, and sometimes I find a start with a little bit confusing because you have at the end what it starts with. Anyways, forgive me. So here we have a stream for that will emit anytime that the price of the order changes. And here we have a stream that will emit anytime that the currency changes. For that order. Now, with these two streams, we can just use combine latest. Isn't it nice that with RxJS 7, we can use combine latest with an object? Anyway, so we can use combine latest, and every time that there is an update, we're going to spread the initial order with the update so that this emits an update for the order that has been updated. Then we can use this hook inside the order line. We pass it the ID, and we plug the event emitters, and that's it. And this should be working. Perfect. It is working. Awesome. So now it comes that moment where we have to make the base currency price work. I don't know if you remember this, but when we were implementing this using React as a state management library, this was the moment that we had to start lifting state, worrying about re-renders, refactoring the exchange rates component and whatnot. Now here, since we're able to define each piece of state as a derivation of their dependencies, we could create a stream here for the rate of this currency, and then we could combine that rate stream with the price stream and recalculate the base currency price whenever one of those two changes, right? And then we could add the property here, and we'll be done. Then each order factory observable will have the base currency price like any other property that it's derived. So instead of deriving it from external inputs, we're deriving it from other streams. That's it. So let's do that. Here, we want to make sure that anytime that the currency changes, we switch map to the currency rate that we created before. Remember, we said that we will be able to keep deriving from it. So that's the moment to do that. So anytime that the currency changes, we want to switch map to the currency rate stream of that currency. And this is going to give us a stream for the rates of this order. Then for calculating the base currency price, we just need to combine the latest values of the price stream that we already had before and the new rate stream. And anytime that one of these two changes, we recalculate the get base currency price for that order. We add this property here, and we're done. The only thing that we need to do that now is we go to the presentational component, and we use the new property of order. That's it. Let's see if that works. It better work. Yeah, it is working. Awesome. And then one cool thing about this is that if we change the euro, only the order lines that are using the euro are being updated. What happens if we change the Canadian dollar, which is not being used anywhere? Well, nothing updates, nothing re-renders outside of this component. And without using any performance optimization, just by using a reactive state management library, right? It's pretty cool. Yeah, so there's that. Now let's make the add button work. We said before that we are going to be using this empty observable as a placeholder. Now let's bring it to life. This time we're going to be creating a signal, not a key signal because we only have one add button. We're going to be creating a signal for getting the events of when the user clicks the add button. So let's do that. We create this signal, and then we want to make sure that every time that the user clicks on this button, we create a new ID, and that we scan this ID, and that we scan this to produce an array where we put the new ID at the end. Okay, and the initial seed for this scan is going to be the initial order IDs, of course. So we were already using this hook, so we don't need to change anything there. The only thing that we are left to do is we need to plug the onAddOrder event emitter. So let's plug it in. We come here, and I don't know if you remember, but before when we were using React, we had to create a new button component to avoid re-renders, or we were put in that situation where what should we do so that nothing re-renders? Now, nothing like that. We just put here the event emitter, and we don't have to worry about anything. This should be it. Let's see if it works. It is working. Awesome. Now, the last thing, I'll be done with this. This is the trickiest part. You may be wondering, okay, so in React-RxJS, they have this concept of factory observables. Looks very cool because it's kind of weird, right? Like these functions that they receive a key and they give you an observable for that key, and they say that they can do that without triggering memory leaks. Believe me, like we could make a talk just to talk about that, but that's what happens. So how can we now access the properties of these factory observables to compute this value here, right? Because basically what we would like to do is for each one of the IDs that we have in this stream, we want to access this property of the order factory observable so that we can add those ones together, right? So don't worry, we got you covered. We have this util operator that's very useful for us that we call combine keys. So combine keys, it's an operator, a creator operator, that takes a stream of IDs as the first argument and a factory of streams as the second argument. And then it returns a stream that emits a map of values every time that one of the values of the map changes or any time that the IDs change, right? So yeah, we use combine keys, and then we grab the values, we map them, we reduce them, we put them all together, and that's it. And then we have a hook and a stream that we can keep driving from if we want to. Let's see if that works. Okay, it is working. Let's see what happens when we update a currency that it's not being used anywhere. Nothing is being updated. No React re-renders are happening anywhere. In fact, something that is kind of interesting is that if two currencies have the exact same price and we change this one to this one, this is not being re-rendered because its value didn't change, right? Like because the exchange rate of that order line keeps being the same. So we didn't trigger a re-render here, which is pretty interesting. So using a reactive state management library has a lot of benefits. One of them is that we can avoid this. We don't have to constantly be worrying about whether we're going to be triggering unnecessary re-renders or stressing React with unnecessary re-renders. Oh, I forgot to plug here the useTotal hook before. Sorry about that. Now let's have a look at the code that we have produced. So this code can look maybe a little bit intimidating when you're not familiar with observables and with the mental models that we're trying to propose with React-RxJS, but this code has some nice advantages. The first one is that it reads from top to bottom, right? Like very similar to that graph, where at the top of it, we have those entities that don't depend on any other entity. And then we start deriving more complex pieces of state later, right? Anyways, so this is all the code that we've needed for doing the state management, we can isolate it, we can collocate it with a component, and we can keep our presentational components a lot cleaner because they just receive hooks that will let them know when they need to get updated. All right, so at this point, perhaps you are thinking, sure, okay, this is a contrived example. Does this actually scale in a real application? Okay, so yes, it does. Oh, I'm running out of time, so I'm going to have to speed up. Let me present you Reactive-Trader. So Reactive-Trader, this is our super cool open source showcase trading platform that we've built at Adaptive. The code is fully open source and available. You can access it. It's under the Adaptive Consulting organization, and the repo is called Reactive-Trader Cloud. So hold on, I need to speed up. So Reactive-Trader is a key project for us for two different reasons. The first one is that most of our clients are financial institutions that don't want for their competitors to know that we're working for them. That's why it's important for us to have a showcase application so that we can demo our potential clients what we're capable of. The second reason is that Adaptive will foster innovation, and Reactive-Trader is a tool that allows us to experiment better ways of doing things and to share that knowledge, both internally and externally. So this Reactive-Trader, I'm not going to enter into the details of everything that's going on here. There is a lot going on, as you can see. There's a lot of different moving pieces, prices that are being, whoa, what happened here? Prices that are being updated when from a WebSocket API. Lots of derived state, of course. Now, Reactive-Trader is a project that got started many years ago, and it has gone through a number of refactors. The latest refactor started a few months ago when we decided to fully re-architect it using React-RxJS. So in the previous section, we saw how thanks to React-RxJS, we can improve the performance of our React apps by not over-stressing React with unnecessary revendors. However, when it comes to web performance, the most important metric is those ones that have to do with loading times. And probably Lighthouse is the best tool for analyzing those metrics. So was React good for us for improving the loading times of our app? Let's see. These are the performance metrics of the classic version, the one that we had before we did the refactor. And there was a lot of room for improvement, that's for sure. And these are the metrics after the refactor. So the most impressive thing, in my opinion, or what has allowed us to greatly improve the loading times is the fact that we have been able to remove the unused amount of JavaScript that was penalizing us with 2.18 seconds to an amount of unused JavaScript that it's penalizing us with 0.15 seconds. So, well, that on mobile, because on desktop, I think that we are clear. So, yeah. React-RxJS definitely helped us improve the loading times. So how did we do that? Well, by improving the code splitting. Let me explain a little bit how code splitting works for those ones who are not familiar. I'm going to go fast. This is what happens when a web page loads, right? The browser makes a GET request, and then the server returns an HTML file. In this example, it takes about 130 milliseconds from the moment that the request is made until this comes. Then the browser passes the file, and the browser starts making a series of requests. One of these requests is going to be our main JavaScript asset. Then the main JavaScript asset, in this example, it takes about 1 second to get downloaded and uncompressed, and that's fine because that happens outside of the main thread. However, once it's been downloaded and uncompressed, then it takes about 1.4 seconds to be fully parsed, compiled, and evaluated. And this is something that happens in the main thread. Therefore, it's a blocking task. So we should be careful with this, and we should make sure that we don't block the browser for too long. Once the main JavaScript asset has finished loading, if we are not doing any sort of code splitting in an application like this one, we'll start loading the data for the live rate section, this data here. We'll start loading the data for the analytics section, this section here, and we'll start loading the data for this section here, right? It's only until all this data is available that the app is going to be fully responsive, interactive. Now, what happens is that if we don't do any sort of code splitting, we're going to be shipping all this unused code that is eating up all this time that it's slowing down the loading of this data, right? So ideally, we wanted to remove this code from the initial render, from the shell component, from the main JavaScript asset. We want to get it out so we can start this request earlier, right? So this is what most people do when they code split. If you have a state management library that allows to self-contain all the logic for these sections in its chunk, then your main JavaScript asset is going to become a lot smaller, and then you will be able to have each chunk handle their own logic. The only problem is that when that happens, another thing that usually happens is that because the logic is self-contained here, this request will only start after this asset has finished, has been completely downloaded and parsed, okay? And what happens if we use a state management library that's based on a central store, or if we use too much React state at the root component? Well, what's going to happen is that the main chunk is going to be a lot larger, and these small chunks are going to be smaller because a lot of the logic of these chunks got pulled into the main asset, okay? So ideally, we want to have something like this, but we want to go one step farther. In an ideal world, we want to be able to start this request as soon as the main asset starts, while also separating all the logic for these chunks, okay? And in a super ideal world, we want to be able to preload these chunks on the index.html by using the module preload link, so that whenever this is ready, the application will be fully interactive. So using React-RxJS, it's trivial to get this level of code splitting with just a few small modifications. Let me show you how we did that, okay? We did that by fully leveraging React Suspense. So this is our root component for this. And we can see here how we have the live rates component, which is this section here, and the traits component, which is this section here, and the analytics component, which is this section here, okay? Then we have a resizer here so that we can resize this. Okay, cool. Now, we are going to start zooming into the components so that we understand how we're using the state in each one of them. We're going to put the zoom into the analytics component. So let's put the zoom into this analytics component, which is this section here, and we'll see that it has 3 different sections: the profits and loss, the positions, and P&L. This one here, and this one here. Let's put the zoom into this one. And then let's put the zoom into, so here we have the line chart. This is very complicated. We're not going to get there. Let's put the zoom into this one, which is very simple. It's the component that's rendering the latest position of the analytics. Let's see how that one works. So speeding up, we can see that here we have this hook that uses the history. And now notice that bind, we have not provided the default value to bind this time, okay? So what's going to happen when the history stream has not emitted any values, or what happens if it emits a value and it happens to be empty, the history is empty? Well, then this stream is not going to be emitting any values. So what is this component going to render in that case? With error? Kind of. So the thing is that React-RxJS fully supports React Suspense. So React-RxJS is going to let React know that this component is not ready to be rendered. And then React is going to know that it needs to put some sort of placeholder. So React is going to ask its parent, do you have a placeholder for me? Because one of your children cannot be re-rendered. And then the parent will be like, no, I don't have anything for you. And then React will go like, okay, let me ask your parent. And here we'll find this suspense boundary, which lets React know, okay, since one of the children here is not ready to be loaded, please put this loader while the data is coming. When the data comes, React-RxJS will let React know that the data is ready. And then once all these components inside are ready to be loaded, it will replace the loader with the actual data. The very nice thing about this is that React won't stop the rendering process of all the inner components while there are components that are in suspense. Everything will keep working behind the scenes. So that's pretty cool. So this is nice because now we can use suspense for data fetching, and now we don't have to start constantly worrying about, is this loading, is it not? We can just let the parent component handle it, and the parent component doesn't have to know about the internals of each component. Therefore, in each component, we can collocate the logic that has to do with the state management of that part in that component and derive from it. So we could go one step farther, and we could say, hey, I want to code split these components. So how do we do that? Super easy. We create a core analytics component, and we lazy import it with React Lazy, and we put it here. Now, the same suspense boundary that we were using before for data fetching, we can use it now for code splitting, which is super interesting. And just like that, we're halfway there. But there's one last thing that we would like to do. We like to start the request as soon as possible. So that's super easy. We just go to the analytics service and we start the subscription. So as soon as the core, as soon as the shell component gets rendered, which is the main asset, as soon as it gets evaluated, actually, the main subscription will start. But this subscription doesn't know anything about the logic of these components. It only knows, because we are deriving the streams, it only knows how to get the data, nothing else. So we can isolate all the logic for these components, and we can collocate it there. And just like that, we have completely code split our application. And without compromising the way that we write our code, which I think is super cool. One last thing that I'm going to be talking about, I'm just going to make it just in time, code navigability. So one big advantage of using streams is that we can easily code navigate our code base. The reason being that since we have this orthogonal graph that we are putting that we're putting together with the tree view, whenever we want to understand when a value comes from, for instance, let's imagine that we want to know where this default value comes here. Let's say this is the default notional value. We want to know, like, where is this coming from, right? So naturally, we'll go to the notional input component, which is this one, and then we'll see here that there's a default notional that comes from this use default notional, right? So if we go to the use default notional, we can see that it comes from this hook, and then this hook, we can see that it comes from the currency pairs. Okay, and then, okay, this comes from the services. Let's code navigate to it. Now we have code navigate to the services, and we see that it comes from these currency pair updates. Then if we don't know where this comes from, we just need to code navigate. So we can keep code navigating without using grep or using find all references, which makes the maintainability of the project a lot easier, at least in our opinion. So here we have code navigated from a leaf component all the way up to the client of the projects, right? So it's pretty cool. And we can keep going, right? We can go to the get stream and we can keep code navigating. So there are no layers of indirection, making the maintainability of the project a lot better. Okay. Yeah, that's it. One last thing, the trade-offs I want to mention really quickly. All things come with their trade-off, of course. We've seen that there are lots of benefits with React-RxJS, but there's also a steep learning curve. People have to be familiar with observables, with RxJS, and with the RxJS mental models that we try to propose. And there's a steep learning curve for this. I think it really pays off. I think the return of investment is great. But yeah, it's something to be considered. Server-side rendering. I'm not saying that it's not possible. I have not investigated where it's possible or not. I've investigated very little, but it's not a need that we've had. So I'm not sure if the library is well suited for doing server-side rendering. And another trade-off is that the documentation, at least for now, has some room for improvement. Lots of thanks to Victor Oliva, the co-creator, the co-author of the library. He should have been co-presented with me, but I took the bullet for that one. He's the real genius under React-RxJS. Thanks out to him. Thanks out to Adaptive, the company that I work for. They have been super supportive. They have been believing this idea since day one. This library has grown organically a lot inside Adaptive. So thanks out to everyone at Adaptive that has been supporting me on this. A lot of thanks to the RxJS core team, especially to Nicholas Jameson and Ben Lesh. for their patience with my contributions to the library, and for fostering a community that is so welcoming. Thanks a lot to Cos. He's the author of this of Rex, a really cool project. I find his ideas like truly inspiring. Some of his ideas, I was like, wait, what is this? But I really appreciate the fact that he is able to think out of the box and come out with a super creative and super creative stuff. And I think that we need more of that. And last but not least, thanks out to Daisy Kato. He's the author of a lot of state management libraries that are super inspiring. Jota, Evaltio, React-RxJS. He also put a project to check if things will work with concurrent mode. And I just made it in time. It's been an hour. Thank you all for listening. And yeah, thanks, Jen, for having me, of course. That's it. Thank you.
Thank you, Joseph. That was a very good talk. Okay, yeah, you're right on time. It's perfect timing. Thanks for being one of our speakers again.